Hey guys, in this video we're going to be talking about the other research strategy that we were going to be talking about in AP Psych, and those are correlational studies. In the last video we talked a lot about the descriptive studies, case studies, naturalistic observations, and surveys. And we spent a lot of time with surveys talking about sampling, random sampling, populations, and wording effects. So if you need refreshers, go back and watch the previous video. For this video, we're going to be talking about correlations. A correlation is a study of how two traits or behaviors accompany one another, how they move together as a pair. So think of it as if something goes up in one trait or behavior, the same thing happens on the other side. Okay, so the psych term is, again, the definition: one trait or behavior that accompanies another. This is done mathematically, that there's a data analysis that goes on to understand correlations, and those are represented by something called the correlation coefficient. It's a variable. The variable is R, and it's going to equal a number that is in the range of -1 to +1. So it is a decimal, right? It is almost always shown as a decimal place. And what this means is the closer it is to -1 or +1, the stronger the correlation is, okay? So let's think of an example. If I ask you what is the relationship between height, how tall someone is, and how much they weigh, you can probably guess that as people get taller, they tend to weigh more. Sure, there might be outliers, but in general, as people get taller, they tend to weigh more. That is what we call a positive correlation, okay? That as one trait increases or behavior, so does another, right? So in this case, as weight goes up, or in this case, as height goes up, so does weight. Notice that the relationship, my slip of the tongue there, also works. That as if you tell me someone's weight, that you can probably somewhat accurately guess, if there's a strong enough correlation, roughly how tall that person will be. That is a positive correlation, because if you graph that data, it's the line that connects the data points, the averages, is going to be a positive slope. For my math nerds out there, right? That's how that works, right? It goes from kind of the corner of the coordinate plane, the middle, towards the outside. I have no idea if these hand gestures work on the video screen, by the way, so just bear with me. A negative correlation is not necessarily something that is bad, but it means that as one trait or behavior increases, the other decreases. So an example could be time spent running on a treadmill and weight. That is a negative correlation, because as the time increases running on the treadmill, the weight that someone will weigh will decrease. Okay. Notice that it can all be about how the phrase is worded. If I talk about ice cream consumption and weight gain, then that is a positive correlation, right? As you eat more ice cream, you gain more weight. But if it was phrased as ice cream consumption and weight loss, well, that's a negative correlation, right? Because as one goes up, the other goes down. Correlations are great at showing relationships between two or more things, right? Two or more traits or behaviors, right? So I like saying that because the word relations, right, is in correlations. So correlational studies talk about the relationship between two variables. There is something called a weak correlation, and that is where it is, despite plotting, despite math analysis, well, not the course, but data analysis, you get a correlation coefficient near 0. That means that there is no correlation between the data, and plotting on what we call a scatter plot really helps show what this data looks like. So a couple things to keep in mind. The closer to 1, either +1 or -1, the stronger the correlation. In nature, in the wild, we're excited if we see correlations at like 0.8 or -0.8, right? That is a very, very, very strong correlation. So keep that in mind, right? If it's closer to 0, that means it's a weak correlation. There's not much of a connection between the two traits or behaviors. So let's take a look at some data. So here is two tables that show the height of 20 men and their temperament scores on a personality inventory. Okay, so temperament just basically means like how likable are you? How nice are you? So just looking at this data, it's hard to see if there's any connection between the two, right? Just looking at this raw data, is there a connection between how tall someone is and how nice they are, how likable they are? It's hard to see. Like I'm kind of taking my time here talking about this to hope that you're going through and looking at this and trying to find any relationships here. But if we plot it on a scatter plot, right, which is basically an X and Y axis, turns out that there is a positive correlation between height in inches and temperament scores. Okay, you can see that if you were to draw a line through this data, right, a solid line, that you would get a positive slope, right? Even though there are outliers, and there are plenty of outliers, the slope tends to be positive. Okay, so scatter plots, plotting the data on a scatter plot like this is really, really helpful to see if there is a correlation that we're talking about or not. And this is kind of the data that we usually see in psychology. It kind of looks like that, right, in terms of how strong that correlation is. So let's look at another scatter plot. I told you about height and weight earlier. So this is the data. So you can see that there's a pretty strong, right, about 0.8 correlation, positive 0.8 correlation between height and weight. As height goes up, so does weight. As weight goes up, so does height. Now, a negative correlation is going to look like this, right? You can see that has a negative slope. Again, for my math nerds out there. So this is mean average annual temperature and elevation in Nevada. So as elevation goes up, temperature goes down. That makes sense, and that's what we see in the data. So these correlations, I'm going to show you a weak correlation or a no correlation. And that is back when we had the draft with the Selective Service, they made it so that there was no correlation between the day that you were born and the draft number that you received. If there was a correlation here, that wouldn't be fair, because that would show that, say, the people who were born later in the year either had a higher or less likely chance of being drafted, and that doesn't seem fair to people. So what they did was they intentionally made sure that the draft numbers and people's birthdays had absolutely no correlation together. And that's what that would look like on a scatter plot. Okay? So let's talk about these correlation coefficients, right? So I told you before that it's R is the variable that we use for correlation coefficients. And we talked about that it is either a positive or a negative number, right? It ranges from positive 1 to -1. So keep in mind that a plus sign or a minus sign here means the direction of the correlation. It doesn't talk about strength at all, right? It is just the direction of the correlation is either positive correlation or negative correlation. And then the number, if you want to think of it as absolute value, the number closer to 1 is a stronger correlation, closer to 0 is a weaker correlation. So positive 0.37 is a relatively weak, although still there, positive correlation. Okay. The good news for us in AP Psych is we do not ever need to calculate the correlation coefficient. We just need to know what it means, okay, and how to read it. We don't need to calculate it. If you're in stat, you might need to calculate it. But in AP Psych, our math isn't that much. We do have some math, but it's not that much. And knowing how to do a correlation coefficient doesn't matter. Knowing what it means matters a lot. Something else that matters is how data gets organized, right? So if we're looking at these two charts, let's say that you are, working for a trucking company, and you're looking at a chart, and you look at the one on the left, and you're like, oh my gosh, we're crushing we're crushing our competitors. Look how much better we're performing than them. And that's true, they are better performing. But if you zoom out a little bit and take the scale, instead of being 5 percentage points and taking it back to 100 percentage points, it doesn't look that impressive anymore. right? It's not that stronger than the competitors. It's about the same. It's just slightly better. And when we get to the end of this unit, we're going to be talking about things like statistical significance. How important is it that there is an advantage here or not, right? Is that advantage statistically significant? But what I'm pointing out is that how data gets organized matters. Now, for our purposes here, for the correlation coefficients and scatter plots and stuff, it actually usually doesn't matter if what you put on the X or Y axis, right? You should still have, if it's a positive correlation, it should still be positive. If it's negative, it should still be negative. So let's talk about why we use correlations at all, right? They're kind of a weird thing. It's kind of looking at two different sets of data, but correlation studies allow us to predict things. If you tell me how tall you are, I can roughly guess how much you might weigh, right? Because I know that there's a point, what was it, 0.79 or something like that, correlation, positive correlation between weight and height. So it allows me to predict certain traits or behaviors if I know what the correlation is. But something that correlation does not do, correlation does not equal causation. Just because two things have a high or even a very, very, very strong correlation, it does not mean that one thing causes the other. Okay? This is a fundamental truth in AP psychology. This is something that gets asked every year on an FRQ, on the AP exam, and probably 2 or 3 times during the multiple choice portion of the exam. Correlation does not equal causation. We can determine what types of things cause behaviors, but correlations do not tell us that. Okay? They only tell us what the relationship is between two things that we're studying. So let's take a look at a real life example. There is a correlation between TV watching and GPA. And I'm going to pause here for a few seconds to ask you at home to think about what that correlation would be. Was it a positive or a negative correlation? Okay. Hopefully you realize that the one we're going for is it's a negative correlation, right? That the more TV you watch, the lower your GPA, right? Notice I can also say the lower your GPA, the more TV you watch, right? That is still a negative correlation, even though it sounds like more TV equals, a positive thing, both in terms of positive value judgment and positive, like it's more. So there's adding. It's not. As one goes up, the other goes down. So what do we know about cause and effect? If we know that there's this correlation, what does that tell us about what is causing something? Is TV watching causing the lower GPA? That's certainly possible, right? You're spending all your time watching TV that you're not doing your homework, which causes you to get a lower GPA. But the reverse could be true, right? A lower GPA could cause you to watch more TV. Maybe you've given up on school because you got in a fight with a teacher or something. So you decide to just blow off all your schoolwork and spend your days watching TV, right? That could cause this connection here. This could be the root to the connection. Or there could even be a third thing, right? A third variable that we're not accounted for here that could cause both the amount of time you watch, amount of time you spend watching TV and your GPA. In this case, it's low intelligence. Maybe it's true. I don't know. I'm not going to say anything. I love watching TV. What does that say about me? Who knows? Oh my gosh. But what I can say is that sometimes there are these third variables, right? So in stats, a lot of times these are called lurking variables or hidden variables. For our purposes in psych, we usually call them confounding variables, which we'll talk more about in the next video. But if there's a third variable that could cause those two things, it's a correlation, right? We can't say anything about which one thing causes another thing, right? Remember that. That is so important for us to get an understanding of. That correlation does not equal causation. I literally can't say it enough. Okay. Sometimes there are things that are called illusory correlations, where we perceive things to be related when they aren't necessarily. And that leads us to this idea that random might not actually seem random, right? Imagine being dealt the hand on the left here. Those of you that play poker know that that is a royal flush. That is the best hand in poker. It beats all other hands. It is the highest straight flush that there is. And you look at the other hand and it's trash. Again, for my poker players, that is probably one of the worst hands that you could have playing 5-card poker. There's no pairs, there's no straight, there's no flush, there's nothing, right? But we might look at getting dealt that royal flush as extremely rare, right? Oh my gosh, look, what are the odds of me getting that? Well, turns out the odds of getting both of these hands dealt to you is exactly the same, right? It's statistics. It's you're getting dealt 5 cards out of 52. The odds of you getting one versus the other are exactly the same, 1 in 2.5 million. We just tend to place value on one of these hands and not the other. If the best hand in poker was a 9-3-5-8-6 all offsuit, then we would be, oh my God, I can't believe we've got the 9-3-5 or 8-6. Like, we would be freaking out about getting that dealt when we're playing poker with our friends. Instead, because of the values that we assign, we put the value on the straight flush, the royal flush that's here. Now, again, what's my point here? We think of getting one dealt being much more unlikely than the other, right? If you got that trash hand on the right, you might think that you've gotten it a bunch before. You're not even thinking about it. It is what it is. Move on with your life. But if you get that royal flush dealt to you, you think that this is, oh my God, what are the odds? Oh, this is a great hand, blah, 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 right? There's no real connection between these two things except for what we put on them. So that's kind of our talk on correlations and correlative studies, right? So it's a little bit about data, understanding data and how data is organized. It's a little bit about understanding that just because things are correlated doesn't mean that there is causation here. And I'm going to show you guys something in class that kind of hits at that idea that there is this, that we can look at correlations between things that are totally unrelated but happen to be highly correlated. Things that have absolutely nothing to do with each other, and that they have a high correlation because just because two things are correlated doesn't mean that something causes the other thing. So we'll touch on that in class. And any questions that you might have about correlations, it's important that you understand how they work and why we use them, right? We use them to predict either traits or behaviors. That is the name of the game with correlational studies. In the next video, we're going to be talking about experiments, which a lot of people will say is the gold star of psychological study. And spoiler alert, this whole causation thing that we're talking about, cause and effect, if you do an experiment right, you can actually answer that question. So that is our natural transition to the next time. If you guys have any questions, you know how to reach out to me. Take it easy.